Here we are at number 2, and number 2 looks scarier than number 1, but it's going to turn out that it's really not. So we've got, again, a strong acid here. Nitric acid is one of our strong acids. Potassium hydroxide, one of our strong bases. So again, you've got a strong acid, strong base situation. It's going to go as far as it can go. And whatever is left over is going to then result in our overall pH that is there. So this guy here we have to dilute, so that's going to be 50 150ths, because again you're adding 50 with 100 together, so they cross dilute each other. So that's going to be 50 150ths of 0.3 molarity, so that's a third basically, and that's 0.1 molarity of your acid. And this guy over here then is going to be 100 150ths of 0.15 molarity, because again, I started with 100, I added 50 to it, so it's 100 150ths by the time it dilutes each other. So that's going to be 2/3 of 0.15 molar, which, oh, hey, look, this is going to be 0.1 molar OH negative. They are equal amounts. So after dilution, but before reaction, it was 0.1 molarity of strong acid. It was 0.1 molarity of strong base. I could go through the process up here again, but just substituting instead of 0.125, it would just be 0.1 and 0.1. But the process would basically be the same for this, and I don't really have to go through this again. This is equal amounts of strong acid and strong base, so this is going to be a pH of 7.